Hello, welcome to this second presentation on risk and capital budgeting. Now, I just want to take you back to what we did in our previous video. What we did was to look at risk and how we measure risk, and we use the statistical methods. In this case, we used the standard deviation, the expected mean, and coefficient of variation as a way of understanding risk. And we did look at different probability distributions, and from the shape of a distribution, we could tell where the risk is high and where the risk is low. But the most important aspect is just the standard deviation and the coefficient of variation. More so on coefficient of variation, because the coefficient of variation is a clear measure of risk in an investment, especially if you're talking about different projects that ends up having different returns. If they have different returns, then the best measure will be to look at the coefficient of variation as a measure of risk. So we're going to continue from just that and pick up and look at what we call capital budgeting decisions, or how we end up incorporating the risk concept or element into capital budgeting. And if I take you also back to what we discussed in our previous chapter on when we're looking at capital budgeting methods, the net present value, the internal rate of return, the modified internal rate of return, and the payback method. And if I use the net present value as an example, when we were looking at the net present value, we said we look at the cash flows and we determine the present values of all the cash flows, and we sum them together, and that gives us the net present value. In terms of the discounting of those cash flows, we were discounting this using some cost of capital, which ideally that was like, if you remember, we were trying to use 10%. It could be different, but again, we are representing the cost of capital to be 10%. Now, if we are looking at more than one project, we were discounting the cash flows for both projects using 10%. And the reason we were doing so, we were assuming that the risk level in each of the project is the same. And because the risk level is the same in each of the project, then we end up using one number or one discount rate to discount the cash flows. But if you look at projects, by the way, the truth is going to be that you're not going to have projects that tends to have the same risk. You're going to have projects that are going to have different levels of risk. And if that's true, then you cannot then use one number or one rate as your discount rate. So what are we saying? You're going to find out that some projects are going to be are going to have a higher risk than the normal risk. And because of that reason, you need to adjust what you call the risk adjustment risk discount rate. So you're going to adjust the the discount rate to something higher because the risk inherent in that particular investment is also high. So therefore, we need to discount those cash flows for the risky projects at a higher discount rate and not at a lower discount or normal discount rate. So risk, again, we use the coefficient of variation to measure risk. And this is how we go about in terms of the adjustment. So basically what we're trying to say here is the if you have an investment project that tends to have a lower risk, so the lower the risk as measured by the coefficient of variation, we end up discounting the cash flows at a lower cost of capital. So for example, if the risk is 0.3 as measured by coefficient of variation, then of course you're going to use the cost of capital, which is 10% in this example. So your discount rate is going to be 10%. However, if you have a different projects that ends up having a different risk, in other words, a higher risk than the previous project, then what you end up saying, for example, this is project A, and then you have a project B that tends to have a higher risk. In that case, then of course, the risk is a zero point 0.9, and that reason, then you end up using a higher discount rate. In this example, will be 15%. And if you have another project that will end up having also a higher risk than B than A, then of course you're going to adjust the discount rate and use a higher rate than what you used for B and for A. So in other words, you will not discount all the projects using one discount rate. You're going to adjust accordingly, and accordingly you're going to consider the level of risk inherent in those particular investment or project, and therefore you're going to use a different discount rate because the risk is not the same. And I want you to think more about this. So when you're talking about risk here and making the adjustment, what we are really saying is this, that if you're looking at a project A, for example, you might find the discount rate here is the risk-free rate, right? But then we add maybe some inflation premium there. But then you end up having another project which could be like, instead of, let's assume this project was 2 years, right? We're talking about 2 year project. And maybe this project, you can just pick up a number and say this project maybe is like 10 year. It's a 10-year project. And maybe this is a 20-year project. So what I'm trying to show you here is, because this project is going to give us cash flows over a 10-year period, there's also risk inherent in those cash flows. And one of the risks, for example, we can think about, for example, the maturity risk. Because it's too far away into the future, there's a high chance, there's a possibility, there's a probability you might not get those returns as forecasted for that particular investment. And because of that, the maturity risk or maybe liquidity risk, should then be added to the risk-free rate and inflation rate, so that we end up having the 15% than the 10% as for our 2 year projects. So because of that risk being high, we need to adjust this into the future. Now, overall, if you're looking at the risk over time, again, the truth again, if I just use the maturity risk premium as an example to add into this, when companies make estimations or they forecast the cash flows, of course, it's true for you to have an accurate forecast for short investment. It's a 2 year, 1 year, 6 months. Again, there's most likely you're going to forecast this accurately because you could clearly see what is going to happen in a short time. But in the long term, 6 years or 10 years or 20 years or 30 years, it's hard for you to tell, exactly what is going to happen in 20 years from today. So even though you have a project that is assured in you, or you are forecasted for, every year some kind of returns for 20 years, the level of risk in that particular investment is so high because, again, nobody can tell what's going to happen, for example, accurately in 20 years or in 50 years. And because of that reason, then you'll end up that in the future, in the long run, the further you go into time, the higher the risk. So you have a lower risk here. You go into 6 years, you end up having maybe a medium. Again, if I just use the qualitative measures, and here maybe you have a higher risk. So in other words, the longer you go into the future, the higher the risk. the shorter the time, the lower the risk. And again, you could see here again the probability distribution or normal distribution here is basically showing you have the standard deviation here is low, then of course then here, then of course then the 10 years. So in terms of standard deviation here, again you could see this is, you have a lower here, then of course then here, then of course then this. So the standard deviation here is higher than it is for a short-term investment. Again, that clearly depicts what we're trying to say in terms of the longer you go into the future, the higher the risk, and of course, the shorter the time period, the less the risk. Which is, again, it makes more sense. So if you want to reduce the risk, so what companies will do, what firms will do, they will try to build or create a portfolio. And a portfolio is basically a group of investment assets. Or if you think about it in terms of projects, then it will be a group of different projects. So you could either, there are two ways to approach it. Do you want to eliminate the risk, or do you want to reduce the risk? Of course, the truth is, it's hard to eliminate the risk, right? Unless you're going to pick up investment projects that are perfectly negatively correlated. If they are perfectly negatively correlated, then when you lose on one project, you gain on the other. In that case, then of course you eliminate the risk because of choosing those kind of investment. But the truth is, it's hard for you just to choose the perfectly negatively correlated assets. So most likely you're going to choose assets that have some kind of correlation. So if you want to diversify, because the reason why investors diversify is because you want to reduce the risk level when it comes to investment. So to reduce it, you're going to choose some investment that are basically, some where the correlation, for example, could be negatively correlated. They don't go in the same line, so they go in different industries. So highly correlated investments move in the same direction in good or also in bad times. For example, if you have two projects that are perfectly positively correlated, and you have a project A and a project B, and if things go well, if things performs well, if the farms perform well, and therefore this investment will give you a higher return again, and this will also give you again, assuming that perfectly positively correlated. So here we're talking about a correlation of 1.0, right? Let's suppose a positive 1.0. In that case, then of course, as this goes up, this also goes up. And therefore, you don't eliminate the risk, or you don't reduce the risk with this kind of investment, because again, if something goes wrong, it's the same thing here. You also lose there. In that case, you don't eliminate or you don't reduce the risk by choosing two or three investment that are positively correlated. So if you want to reduce the risk, what you're going to do is you're going to have A and B, and what you're going to try to do is where, again, if you choose the perfectly negatively correlated, where we're talking about a negative 1.0, in this case, then we're saying if you gain here, you lose here, or if you lose here, you gain here. In that case, of course, you're trying to, in this case, you're trying to eliminate the risk, right? And again, it's not possible really, but you're going to eliminate the risk in totality by choosing two perfectly negatively no two negatively correlated assets or investments. So what you want to do is to try to reduce the risk. And to reduce the risk, it means you are going to choose investment or a portfolio of investments where there is some kind of correlation. Again, it doesn't have to be positively correlated, but if you want to reduce, really what you do is you're going to choose investments that are uncorrelated. Again, you could choose with some kind of correlation, the 0.2 or 0.3 correlation. There's some correlation there. It just you reduce some amount of risk, right? But again, if you want to achieve the best reduction in risk, you're going to choose investment that are uncorrelated. Why am I saying so? For example, look at so what I mean by this is this: you're going to choose investments, for example, that are going to be in different industries or different sectors. For example, you could want to invest in the airline industry, and you also invest in pharmaceutical industry, right? These are two industries that are different, and therefore there's no correlation in the investment in those two companies or industries. So if you invest in pharmaceutical and in airline, then of course you have there's no correlation really. So in other words, if something happens with the airline industry, it most likely it is not going to affect the pharmaceutical industry, or something happens with the pharmaceutical industry is not going to affect the airline industry. So in this case, you're reducing the risk of your investment by investing in uncorrelated industry. But if you go and invest in the same industry, let's say you go invest in Southwest Airlines and you go invest in Delta, they're all in airline industry. And if you're going to invest in both industries, again, if something goes wrong with one, it could also go wrong with the other, because those are basically perfectly correlated industries. In that case, you don't want to do so, because if you do so, you are not reducing the risk. To reduce the risk, it's better to choose uncorrelated investment or industries, and by so doing, you'll be reducing the risk. So we look at this concept of coefficient of correlation just to give you an idea where we are saying you don't want to choose a perfect correlation between the two investments. If you want to reduce the risk, you want to make sure that you're choosing investments where the correlation is not perfect. Again, it could be a minus zero point 0.2 and another investment a point 0.04, what so you're trying to choose some kind of combination that is not perfect to the extreme of one and to the extreme of negative one, right? So you're trying to seek some kind of combination in between, and by so doing, yes, you'll be reducing the risk. But the best way to go again is to choose investment or projects in different industries, because that's a sure way of trying to minimize the risk. Combining, so risk can be reduced by combining risk assets with low risk or negatively correlated assets. So that's one way of you trying to reduce the risk in a portfolio. But the reason why you buy a portfolio is because you want to reduce the risk. So you want to make sure that the products in that particular portfolio are, again, the correlation is very key. So you want to make sure that if one asset goes down, it shouldn't affect the other asset, by going down the same direction. Because if that was the case, then of course you will not be eliminating or reducing the risk if you do. So again, I hope this information helps, and we're going to move further by just cutting this conceptual overview of coefficient of variation, coefficient of correlation, the standard deviation, the the expected mean. We're going to cut this information and try to move further and try to apply some numbers or some computations to these issues. By applying some computations, it's going to be make more sense, and you're going to understand this in more clear manner. Because I know sometimes, from a conceptual view, if we add some numbers there, then you will see a bigger picture of the entire chapter.